You are given exactly 60 seconds to answer this question. If you're done with your answers, you can skip the timer and proceed to the discussion portion to verify whether your answers are correct or not. If you may, you can share your answers as a comment in the comment section below. If you need more time, you can pause this video in any moment you want. Your 60 seconds starts now. The coordinate of the terminal point of the arc, which is pi over 6, is just very easy to remember. You can even memorize that. But it's also important for us to understand how was that point or coordinate came into being. So we're going to illustrate it here. Let's consider this unit circle here. As mentioned, this is considered to be a unit circle because the points on this circle has a distance with the center being equal to simply 1. That's the distance of the points on this unit circle to our center. So if you have this, the distance is 1. Even if you have a point here and you take that distance, that's just equal to 1. Hence, unit circle. And we all know that all radii of the same circle are just equal. So with whether you draw it here or from there, you will have equal to 1. Now, our goal here is to look into the special coordinate of our pi over 6. Again, it's very easy to remember, but this is how it came into being. Okay? Our pi over 6 is somewhere here. We're going to illustrate it later, but let's start by looking into the conversion of pi over 6 into degree measurement. Because pi over 6 is actually a radian measure of an arc or an angle. It has an equivalent degree measurement, and we're going to use the idea of degrees because we're going to illustrate the initial or the terminal point of our arc pi over 6. We can use this conversion. When we convert a radian measure into an equivalent degree measure, you're just going to use this ratio, 180 degrees over pi. This is what we are going to use when we convert a radian measure into an equivalent degree measure. Because we are going to remove here our pi. And as we divide 180 divided by 6, you will have equivalent of 30 degrees. Hence, pi over 6 in terms of degrees would be equivalent to 30 degrees. And if we're going to draw it on our unit circle here, the terminal point of pi over 6 is somewhere here. Because it's 90, probably 60, 30 is somewhere here. So our terminal point for pi over 6 will be at this point here. And we're going to show the value of the coordinates of this. Of course, it's a combination of x and y values. Now, to do that, please be reminded of that for a central angle, because this is a central angle here, the central angle is just equal to its intercepted arc. This is pi over 6, or also known as 30 degrees. So this is 30 degrees as well. Now let's try to draw a vertical line from our terminal point perpendicular to our x-axis. As you can see, if it's a vertical line, let's do it again. If we are going to draw a vertical line, then we are going to have perpendicular lines here. This would be 90 degrees now. This is actually, again, the terminal point of pi over 6, because this is pi over 6 here. This is pi over 6, which is also equivalent to 30 degrees as mentioned. We know that the radius is just 1. And this here, the height, corresponds to our x-axis, y-axis rather. Therefore, this is y. Not the arc, but this y, the vertical line here. And this horizontal line from the center, not until the point, but this point here is just equal to x. This would mean if we are going to solve for the distance of the center to this point here, not the point in the circle, but somewhere here, that's equivalent to the x value of the coordinate of our terminal point for the arc pi over 6, and the height is just equal to y. Let's try to zoom it in here and draw a similar figure here. So if we're going to have a larger version of that, hopefully that it's okay for us. My drawing might not be that very accurate. So we have here 90 degrees. This again is the terminal point of pi over 6x and then y. That's the terminal point. This is our radius of 1. This is our y, the vertical line, which corresponds to this. And x here is our horizontal line here. Okay, so we know this already to be 30 degrees, as this is equivalent of the arc pi over 6. And we know that the according to the triangle angle sum theorem, this would be 60 degrees, because for a triangle to be a triangle, the sum of the measurements of the interior angles is equal to 180 degrees. We already have 30, we have 90, and we have 60 degrees. At this point, we have a special right triangle 30, 60, and 90 degrees. We have 30, 60, 90 degrees. Okay? And we have a special relationship as to the shorter leg represented by y and the hypotenuse, and our shorter leg to our longer leg, which is x. And here comes the idea of the 30, 60, 90 degree angle. From the shorter leg, which corresponds y, going to our hypotenuse, okay, from our shorter leg to hypotenuse, we simply multiply it by 2 or times 2. We double it. That would mean if we are going to return from the hypotenuse to our shorter leg, the reverse operation is to divide it by 2. And since our hypotenuse is just 1, our y is 1/2 of 1, or in short, 1/2. This is the y value of the coordinate of the terminal point of our pi over 6, which corresponds to the height of that point here. So that's y already. So we're done with that. After that, there's also a good relationship between the shorter leg and the longer leg. As we move from the shorter leg to the longer leg, we simply multiply it by square root of 3. That would mean the value of x is equal to y, the value of y, times square root of 3. Our y earlier is already 1/2, and we multiply it by square root of 3. We know that square root of 3 can be over 1, and when you multiply fractions, numerator to numerator, you will have 1 times square root of 3, you have square root of 3, 2 times 1, 2. This is your x, or the distance from this point to this point of our right triangle, which corresponds to the x value of our coordinate. In short, with y, which is 1/2, and x being square root of 3 over 2, the coordinate of our pi over 6, to which we already knew, as I mentioned, because we can memorize it, but just for the purpose of discussion, the reason behind the point is this. And again, the coordinate of pi over 6, which is this point here, the terminal point of pi over 6, is a combination of your x, square root of 3 over 2, and your y, which is 1/2. And this is the origin of that point that you were able to memorize pertaining to pi over 6 and all other angles or arcs in the unit circle with denominator of 6. Thank you for watching.